a 5% solution, weight per weight of a cane sugar, molar mass 342, has a freezing point 271 Kelvin. What will be the freezing point of 5% glucose, molar mass 180, the glucose solution in pure water, if a freezing point of a pure water is 273.15 Kelvin? So first of all, you should understand delta TF, that is depression in the freezing point, is directly proportional to molality. Therefore, it is equal to Kf into molality, where Kf is the molal freezing point depression constant. In the first data given, the molar mass is given and the freezing point is given. Therefore, for the first case, the delta T, that is depression in the freezing point, is 273.15 minus 271.0. So the freezing point depression is this much. So the molality has to be calculated. Then Kf can be found from this information. So Kf, the molal freezing point depression constant, is equal to, it is delta Tf by molality. So molality is weight of the solute divided by molecular weight of the solute. So that this will give you a number of moles. If this much of mole is present in this much of solvent, so this is weight of the solute, this is weight of the solvent, what would be the number of moles present in 1000 gram? So this is molality. So this entire molality has to be inverted. So this is 2.15. So you can substitute all these values here. So the Kf is equal to 2.15 multiplied by M2, the inverse, by W2 into W1 by 1000. So all the values are given. 2.15 into molecular weight is 342 and it is 5%. So 5% means it is 5 gram in 100. 5 gram in 100. So the remaining 95 gram is the weight of the solvent. So divided by 1000. So this is the Kf value. Now delta Tf is to be calculated. Again, delta Tf, the Kf is given, the molality of the other substance has to be substituted. All the simplification can be done at the end. So Kf is 342 into 95 divided by 5 into 1000. And the molality for the second case, is again weight of the solute divided by molecular weight of the solute into divided by weight of the solvent into 1000. So for the glucose, the weight is again 5 gram. Molecular weight is 180. So if 5 gram goes from 5% solution, 95 is the weight of the solvent into 1000. So this entire value will take the place of the molality here. So into 5 divided by 190 into 1 divided by 95 into 1000. So I have done like this to simplify. So this 1000 and this 1000 will go off. The 195 will go off. And this 5 will go off. And what remains is 2.15 into 342 divided by 180. So if you do the simplification, you are getting 4.085 Kelvin. So this is the depression in the freezing point. So the actual freezing point of the water will be 273.15 minus 4.085. So the answer will be 269.07 Kelvin. So 5% glucose solution will freeze at 269.07 Kelvin if 5% cane sugar solution freezes at 271 Kelvin. So the first part of the question is used to find out the molar freezing point depression constant. And the second part, we are doing the actual calculation. And the answer is 269.07 Kelvin.